Today we're going to go over the mean value theorem definition, the theorem, and we're going to do just two problems today. Okay, so the mean value theorem for integrals states that a continuous function on a closed interval takes on its average value at some point in that interval. The theorem guarantees that if f of x is continuous, a point C exists in an interval a to b such that the value of the function is equal to the average value of f of x over the closed interval ab. So in other terms, we can rewrite this so that the theorem states that the function f of x, if the function f of x is continuous over the closed interval a to b, there's at least one point C that is equal to the closed function ab, such that f of c is equal to the average is equal to 1 over b minus a, the integral from a to b, f of x dx. This formula can also be restated as the integral from a to b, f of x dx is equal to f of c, b minus a. Okay. So basically what this problem is saying is that if there is a function and this function is continuous over two sets of numbers, they're saying that at least one point in this continuous function within the bound is going to be equal to the average value of the closed interval. Here's the proof for that. If you want, take a look at that. But I'm not going to. Okay. So let's go ahead and do this first problem. Find the average value of the function f of x 8 minus 2x over the interval or over the closed interval 0 to 4, and find c such that f of c is equal to the average value of the function over the closed interval 0 to 4. Okay, let me go ahead and open my notes. Okay, so let's write down the things that we need to know. We know that the function is this equation. And then in terms of the known function, our known is that f of x is equal to 8 minus 2x. The bounds are 0 to 4. And then we know that f of c is equal to the average value. Okay? So this is going to be our b, and this is going to be our a. So when I'm rewriting this in terms of the a and b, it's going to be 1 over 4 minus 0 times the integral from 0 to 4, 8 minus 2x. Okay. And now that we're here, we can go ahead and continue on by simplifying further, finding the integral, and so on and so forth. So this is going to be 1 over 4 8x minus x squared 0 to 4. This becomes 1 over 4, 32 minus 16, which ends up being 16 over 4. which is equal to 4. Okay. Now that we found the average value, now we want to set the average value equal to C. And the reason why we do that is because in the problem below, it says to find C such that f of C equals the average value over the function between this bound. So now that we know that the average value is this, we can solve for C. So in order to do that, you're gonna set the average value equal to f of C and then solve. So we're gonna go back to this equation here and plug it in. So f of C is 4 is equal to 8 minus 2, 4. Wait, this is wrong. Oops, I'm so sorry, guys. F of C is equal to 8 minus 2C, which is also equal to 4. There we go. So the reason why we're finding it like this is because this function is basically saying that the average value is equal to the function here. So now we just want to simplify further. So I'm going to subtract 8 on both sides and then get rid of the negative, which gives us 2C is equal to 4. And then C is equal to 2 after you divide away the 4. So you divide the 2 on both sides. So that means at C equals 2, f of 2 is equal to 4. Okay. So now that that is done, I'm not gonna write out this second problem. I'm just gonna explain it to you guys. So we're gonna go ahead and do example 5.16. Given that the integral from 0 to 3 x squared dx is equal to 9, find C such that f of C is equal to the average value of f of x equals x squared over the closed integral or closed boundary 0 to 3. So it's basically the same problem that we had before. When you're solving this problem, you want to use the mean value theorem that we just went over at the beginning of this video. We're going to set A equal to 0 and 3 equal to B. Then we're going to multiply it by the integral from the bound 0 to 3 and the function given x squared dx. Plugging in these values, the integral of x squared is x cubed over 3. And then when you are finding when you're finding the definite integral, after that, you're going to get 1 over 3 is equal to 9, or times 9 is equal to 3. So then that means that the average value is 3. And we're basically going to redo everything that we just went over. And we're going to set C, or we're going to plug in C into x squared, since we're setting it equal to the function given to us. So then we're going to, since we're setting the function equal to C and our average value, it's going to be C squared is equal to 3. And then you want to get rid of the squared, which means that C is equal to plus or minus square root of 3. And since negative square root 3 is outside the interval of x squared, we don't need to take that into account. Plus the answer is really just the square root of 3. And there it is on a graph. Okay. Thanks, guys. In the next video, we're going to continue with 5.3 and we're going to talk about the fundamental theorem of calculus.